Run Nemotron 9B on vLLM with OpenAI-Compatible API. Introduction. Recently, an article on Kita titled Running Nemotron Nano 9B v2 Japanese with Llama.cpp gained significant attention. That article required manual building of Llama.cpp and GGUF conversion as a workaround for Ollama's zero-division bug, but this article introduces a simpler and more practical approach, vLLM plus OpenAI-Compatible API. Using vLLM eliminates the need for GGUF conversion, avoids Ollama-related issues, and allows for direct reuse of existing code. The entire process, from server startup to API integration, can be completed with just 3 commands. Why vLLM? Direct safetensors loading eliminates the hassle of GGUF conversion. Models can be used immediately by simply specifying the model file at server startup. Standard OpenAI-Compatible API, by setting to existing OpenAI SDK code works out of the box. NVIDIA proprietary architecture support natively supports the Nemotron_H hybrid architecture of Mamba 2 Plus transformer. Trouble-free, no need for Ollama bugs or manual Llama.cpp builds. It's a simple 2-step process, and setup procedure. Note that is a fast package manager written in Rust, used here as an alternative to. Can be used just like, but dependency resolution is several times faster. Of course, also works without issues. Upon startup, an OpenAI-compatible REST API will be available at. The model will be automatically downloaded from Hugging Face the first time, and loaded instantly from the cache on subsequent runs. In an RTX 5090 environment, it takes approximately 30 seconds from model loading to API ready. The power of OpenAI-Compatible API. Local models can be utilized by changing just one line of existing OpenAI code. Streaming generation is also supported by default, and a dummy API key is sufficient. What this means is that existing applications written using the OpenAI SDK can switch to a local LLM with just a one-line change to the no API key required, zero cost, no external data transmission. This compatibility is the biggest reason to choose vLLM. Real-world use cases. I actually use a single vLLM server shared across multiple applications. All of the following are examples currently in production. Web chat, Streamlit plus Brave Search RAG. I built a RAG chat that injects search results obtained from the Brave Search API into the context to generate answers based on the latest information. Since it's a local LLM, there are 0 API costs, and you get search-augmented answers. Multi-tool with Flutter Web UI plus Flask API. A Flask API server, port 5001, acts as a proxy to vLLM, shared and utilized by multiple tools built with Flutter Web. The following tools were implemented on the Flutter Web side. Blog Generator converts Claude code development sessions into articles. File Q&A asks questions about the content of local files. Git Story transforms commit history into a narrative. All tools operate on a single vLLM server. Automatic blog generation from Claude code history. We automatically generate blog posts by feeding Nemotron the session history, SOML, from Claude code. This mechanism was actually used to generate the following articles. Shogi AI, ONNX conversion and parameter tuning for a 20B model. The illusion trap that befalls developers who don't read readmes. Implementing patent LLM's billing system with Stripe checkout. Since the trial and error during development directly becomes material for articles, the problem of not having time to write blog posts is resolved. Minecraft AI bot. Nemotron was utilized as the brain for NPCs in Minecraft. Brain.py connects to localhost 8000 and generates NPC actions based on the player's situation. This is a unique application of a local LLM, allowing us to imbue NPCs with intelligence without worrying about API costs. Daily report auto-generation, cron integration. Executed by cron at 4 a.m. every morning, Nemotron collects usage history from Claude Code and Gemini to generate a daily summary report. The generated reports are stored in daily_reports.db and used for reviewing development activities. Codebase analysis pipeline. I had Nemotron analyze the Python code from all my projects, 13 of them, and automatically extract reusable patterns. Code templates, 281 items, DB operations, API calls, file I/O, etc. Prompt patterns, 123 items, analysis, text generation, system instructions, etc. Output destination, knowledge.db with FTS5 full text search support. With thinking mode off and max_tokens, 64, classification tasks were processed at 18 items/second. Handling thinking mode. Nemotron 9B has thinking, inference, mode enabled by default, resulting in two output patterns, one with tags and another with a tagless preamble. Okay, let's see. The countermeasures for different use cases are as follows. For JSON output, disable with. For text output, skip to the first heading with. For batch classification, achieved 18 items/second with thinking OFF+. Comparison summary with Kaida article. Item Kaida article, llama.cpp, this article, vLLM. Model conversion GGUF conversion required not required, direct safetensors. Backend llama.cpp manual build. API custom server OpenAI-Compatible, standard. Ollama trap manual build to avoid not relevant at all. Existing code reuse connection code rewrite only change. UI Open Web UI, Docker, customizable, anything can be used. GPU requirements low VRAM support with GGUF quantization 24 GB plus recommended, BF16. It's worth noting that llama.cpp has the advantage of supporting low VRAM environments through GGUF quantization. For environments with 16 GB VRAM or less, llama.cpp might be more suitable. The vLLM approach in this article is most effective in environments with 24 GB or more VRAM. Summary. vLLM can be launched in 3 lines and used directly with the OpenAI SDK. A single vLLM server can be shared and utilized by multiple applications such as Streamlit Chat, Flutter Tools, Minecraft AI, daily report generation, and code analysis pipelines. The true value of local LLMs lies in their ability to integrate seamlessly into your development environment. You're freed from the pitfalls of Ollama and the complexities of llama.cpp. Your existing OpenAI code will run with local models by simply changing one line of. Enjoy zero API charges, no external data transmission, and unlimited usage as long as you have a GPU. I hope this article helps you move from merely trying out local LLMs to actually leveraging them in your work. This article was generated by Nemotron Nano 9 BV2 Japanese itself.